Hello everyone, welcome back to JP Study Corner. Today we are going to see some most important information about instrumentation basics. Instrumentation. Instrumentation is a field of applied engineering. Two kinds of instrumentation, they are process and discrete automation. Process automation involves sensing, measurement and control of continuous varying process variables like pressure, flow, level and temperature. Discrete automation involves sensing, detection, sequential control, motion control and material handling. Example, car assembly, bottling, etc. Instrumentation enables automating process and operations. It enables centralized display and monitoring of process parameters. It eliminates and minimizes human intervention and enables optimum performance of plant and machinery. It facilitates auto-triggered response to process parameters approaching criticality and it enhances safety. Elements of instrumentation are detection, control and actuation. Detection. Sensors such as ATG, TFM, RTD, thermocouple, pressure transmitters, densitometer, overspill sensor, limit switch, push button. Control. DCS, PLC, BCU. Actuator. Control valves, MOVs, on-off valves, DSSV. ATG. ATG stands for Automatic Tank Gauging Level. By using frequency modulated continuous wave method, level gauge transmitter microwave signals with a continuously varying frequency towards the liquid surface. When the reflected signal returns to the antenna, it is mixed with the outgoing signal. Since the transmitter continuously changes the frequency of the transmitted signal, there will be a difference in frequency between the transmitted and the reflected signals. The gauge mixes the two signals, resulting in a low frequency signal which is proportional to the distance to the liquid surface. ATG employs a multi-spot thermometer. The multi-spot thermometer measures temperature with a number of PT 100 spot elements placed at different heights to provide a tank temperature profile and an average temperature. Only the elements that are fully immersed are used to determine the product temperature. The spot elements are placed in a flexible gas-tight production tube made from convoluted stainless steel. Capacitive type pressure measurement. The parts are lead wires, capacitor plates, sensing diaphragm, rigid insulation, oil fill, welded seals, isolating diaphragm. And next is piezoelectric type pressure measurement. The parts are electrical connector, integrated circuit amplifier, housing, preload sleeve, seal ring, accelerator compensating quartz plate and mass, quartz sensing element, flush smooth diaphragm. Thermocouple Principle. A thermocouple is a device made by two different wires joined at one end, called junction end or measuring end. The two wires are called thermoelements or legs of the thermocouple. The two thermoelements are distinguished as positive and negative ones. The other end of the thermocouple is called tail end or reference end. The junction end is immersed in the environment whose temperature T2 has to be measured, which can be, for instance, the temperature of a furnace at about 500 degrees Celsius, while the tail end is held at a different temperature T1, example, at ambient temperature. Because of the temperature difference between junction end and tail end, a voltage difference can be measured between the two thermoelements at the tail end. So the thermocouple is a temperature voltage transducer. RTD principle. Resistant temperature detector utilizes the characteristics of the metal which changes its electrical resistance with temperature. For pure metals, this relationship may be expressed by RT equal to R0 of 1 plus AT plus BT square plus CT cube plus etc. where R0 equal to resistance at reference temperature usually at 0 degrees Celsius. RT equal to resistance at temperature T. A equal to temperature coefficient of resistance. B and C equal to coefficients calculated on the basis of known resistance temperature points. Resistance thermometer construction. Parts are resistance thermometer, connection to leads, connection leads, sheath, insulator. Turbine flow meter consists of multi-bladed rotor assembly suspended in fluid stream on free-running bearing. Fluid impinging on rotor blade causes rotate to revolve. Angular speed of rotation is directly proportional to volumetric flow rate. Speed of rotation is monitored by magnetic pickup. Turbine flow meter consists of permanent magnet, cone, coil, meter body, blades and reluctance pickup coil. Densitometer. Densitometer. Densitometer is used to measuring the density of the liquid. Here, M by T equal to Y by R2 omega, where M equal to mass, Y equal to torque, R equal to radius of gyration, omega equal to angular velocity. Sensor tube is driven by magnetic coil and it vibrates similar to tuning fork. Fluid flowing inside the tube pushes down the tube and fluid flowing outside tube pushes tube upwards. This twisting characteristic called Coriolis effect. As per Newton's second law of angular motion, amount of sensor twist is proportional to mass flow. Digital set stop valve. DSSV valve consists of two solenoid valves, that is, normally open and normally closed solenoids. It located in the upstream and downstream portion of the control loop respectively. It controls the operation of the valve. With both solenoid energized, high upstream pressure is blocked, allowing the product in the cover to vent the low downstream pressure, opening the main valve. Conversely, de-energizing both solenoids allows high upstream pressure to close the valve. In this picture, the first image shows the valve closing of control valve and the second image shows the valve opening of control valve. Control valve. The most common final control element in the process control industries is the control valve. The control valve manipulates a flowing fluid such as gas, steam, water or chemical compounds to compensate for the load disturbance and keep the regulated process variable as close as possible to the desired set point. In this figure, we can see inherent valve characteristics. In this image, we are going to see direct acting actuator. Its parts are loading pressure connection, diaphragm casing, diaphragm and stem shown in up position, diaphragm plate, actuator spring, actuator stem, spring seat, spring adjuster, stem connector, yoke, travel indicator, indicator scale. In this image, we are seeing about air to open valve assembly. Its parts are compact field reversible multi-spring actuator, integral pneumatic passageways, integrated positioner mounting capability, one-piece screwed packing follower, standard live loaded packing, clamped bonnet design. In this image, we are seeing push down to close valve body assembly. Its parts are bonnet gasket, spiral wound gasket, cage gasket, seat ring, valve body, seat ring gasket, cage, valve plug, bonnet, packing box, packing, actuator yoke lock nut, packing flange, valve plug stem. MOV. The motor operated valve has motor, limit and torque sensors, gearing, valve attachment, manual operation, actuator controls, electrical connection, field bus connection. Optical smoke detector. An optical smoke alarm, also called photoelectric smoke alarm, works using the light scatter principle. The alarm contains a pulsed infrared LED which pulses a beam of light into the sensor chamber every 10 seconds to check for smoke particles. It includes a light source such as incandescent bulb or infrared LED, a lens to collimate the light into a beam, and a photodiode or other photoelectric sensor at an angle to the beam as a light detector. In the absence of smoke, the light passes in front of the detector in a straight line. When smokes enter the optical chamber across the path of the light beam, some light is scattered by the smoke particles, directing it at the sensor and thus triggering the alarm. The optical smoke detector consists of optical chamber, cover, case molding, photodiode, infrared LED. Multi-smoke detector. Photoelectric detection of light scattered by smoke particle. Heat, temperature, sensitive resistance. Purimeter or oil content meter. In purimeter, a sample from oily water separated discharge is continuously exposed to a beam of energy. The intensity of transmitted and scattered energy is measured. In order to eliminate effects of any minute variation in the intensity of transmitted energy, a ratio technique is adopted and the resultant output is amplified, processed, converted and displayed in terms of parts per million of oil. Hope this video very useful for you. If you feel the same, please like and comment and don't forget to subscribe my channel for more videos. Thank you.